Hello guys, so we'll be continuing with fitting and turning, of which we're doing forces, so now we'll be continuing under the topic of forces. We'll be continuing with moments found in engineering components, whereby we'll be doing the basic calculations. Okay, so what is a moment? What is a moment? Okay, a moment is the turning effect of a force about a point or axis. Okay, let me try to type here. Okay, let me type. What is a moment? A moment is then a moment is the turning effect of a force. Effect is the turning effect of a force about a point. About a point or axis. We have the formula of moment. Okay, so let me write the formula just here. Moment is equal to force multiplied by perpendicular distance. Perpendicular distance all right, so that is the formula. Oh, and also moment, it is measured in, it's measured in okay, let me write it in expression from me. Moment is equals to F multiplied by D, of which M stands for moment, which is measured in Newton meters. Newton meters. F stands for the applied force. Applied force, which is measured in newtons. And D stands for perpendicular distance from the point or axis and it is measured in meters. And it is measured in meters. So here is the equation. We've got the basic types of moment. So we've got the basic types of moment in engineering, because basically what we'll be focusing on the basic types of moment in engineering. So let me show you the moment type. We've got the moment type. The first one is bending moment. First one is bending moment. Its description. What does it do? Its description. It causes a beam or component to bend. It causes a beam or component to bend. So we are going to go to the second one, which is the torsional moment. The torsional moment what does it do? What is it, or what does it do? It is a twisting moment. It is a twisting moment around an axis. Or there's another word which we can say it, or a torque. Or a torque around an axis. An axis. So we've got the third one, which is the last one. It's a couple. It's a couple. Its description, what is it? It's two equal and opposite forces. Two equal and opposite forces. Not in line. Not in line. Causing rotation. Causing rotation. So now we'll be going in the basic. So now we'll be doing the basic moment calculation. So let's say, for example, you are given, they're telling you, let's do a single force on a lever arm. They're giving you a problem. They're telling you a 200 force, a 200 Newton force. Okay. I'm having network issues. So let me check what's going on. So now we are given a 200 Newton force, which is applied perpendicular to a wrench 0.3 meter long. What is the moment about the bolt? What are we given? We are given we are given a 200 Newton force. A 200 Newton force, and we are also given a wrench which is 0.3 meters long. It is 0.3 meters long. What are they saying? They're saying what is the moment about the bolt. Okay, so what are we going to find now? Since we are given the force and also the distance, so we can be able to find our moment. What is our moment? Okay, Yeah, so we're going to use the formula, which is m is equal to f multiplied by d. So we are given it is 200 multiplied by 0 comma 3. Okay, let me erase this so that it can fit properly. All right, here it is. This equals to 200 multiplied by 0 comma 3. What is 200 multiplied by 0 comma 3? It is 60 Newton meters. That's your answer. So let's go to the second example. All right. So we are doing example 2. Example 2, we are being given, it's a beam with a load. Okay, so what the statement is saying is a 5-meter long simply supported beam has a 1000 Newton load acting 2 meter from 2 meters from the left support. Find the moment at the left support. Okay, so as you can see here, you are given we are given the force and the distance, so it's easier for us to find the moment. So we're going to use our formula, which is moment is equal to F multiplied by D, force multiplied by perpendicular distance. So we were given 1000 newtons. The force that we were given is 1000 newtons multiplied by 2, because we've been given the distance, which is 2. Or let me just say multiplied by 2. It's gonna give us 200. 2000, not 200. 2000. Okay, let me erase this so that it can fit properly. It's equals to okay, here is so, which is equals to 2000 Newton meters clockwise. Okay, let me erase this so I can. Yeah, clockwise. So we are done with example 2. Let's go to example 3. Okay, so example 3, it says two 500 Newton forces act in opposite direction on a beam 0.8 meters apart. The example 3 is a moment of a couple, right? Because what are they saying? They're saying that two 500 newtons act in opposite directions on a beam 0.8 meter apart. So we've been given our force, which is 500 Newton, which is equals to our force, and we've been given the distance, which is equals to 0.8 meters. What are they saying? What do we have to find? We have to find our moment, right? So now our formula is is equal to F multiplied by D. Our force is 500 newtons. Let me erase this. Okay, yeah. Our force is 500 multiplied by 0, 0.8 is going to give us, let me punch this on the calculator, which is 500 multiplied by 0.8, gonna give us 400 Newton meters. So we're done with moments. So right now we are going to go to stress calculations. So for us to calculate stress calculations for us to calculate stress in basic cultural numbers like squares and round bars, we use this formula. Well, think formula for stress is equal to, okay, is stress is equals to F divided by A. So what is A? What does S stand for? S stand for stress. F stands for axial force. Axial. Let me write this. Okay, axial. Axial force. And what does A stand for? A stands for the cross. A stands for the cross-sectional area. Sectional area. Okay, so stress is measured in pascals. Pascals or but commonly we use megapascals, so we'll use or megapascals. So the axial force is measured in newtons. The axial force is measured in newtons, and the cross axial the cross sectional area is measured in square millimeters or squared meters squared or millimeters squared. So right now, so into let's get into the calculations. Okay, so we're gonna start with calculation of a square bar. We are gonna start with calculations of square bar. So let's start with the square bar. Okay, square bar. If the square bar has a side length of a, so the area of the square will be equal to a squared. So let us now calculate. Let's say they are giving you the side a, which is, let's say the side of a is okay, let's say the side a is 10 millimeters. 10 millimeters. What are we going to do? We're firstly going to calculate the area, the cross-sectional area. So it will be a is equal to 10 squared, which is equal to the 10 squared is equal to 100. So it's gonna be equal to it's gonna be equal to 100 millimeter squared. So since we've got the cross-sectional area, we can now substitute in our equation of finding stress. So again, we are looking for stress. So as I said earlier, our equation for stress is S is equals to F divided by A. So we are going to use that equation as we now have A, which is 100, F it's 5,000 newtons. So let's now calculate our stress, because we were given 5,000 newtons as our force. So stress is going to be equal to F divided by A, which is equals to divided by 100. It's equal to, what is 5,000 divided by 100? It's equals to 50 MP. It's equals to 50 MPa. And that's your final answer, 50 MPa. So let us look at an example for the round bar, because again we have the square bar and round bar. So obviously the area for a square bar, it won't be this, we won't use the same formula as the one for a round bar, because the structures are different. It is a square and the other one is round. So right now we'll be looking at round bar, which is a circular cross section. So yeah, let us look at a round bar. Okay, so right now let's the area for a round bar, let me just say circle, because the circle is round. So obviously the area will obviously be, it's equal to the pi of d squared, diameter squared, divided by 4. This is the area of a round bar. The area of a circle actually is, the area of a circle is equal to pi multiplied by d squared divided by 4. So right now we are given a problem. On our problem, we are given the diameter of 10 millimeters and the force of, we are given the diameter. D actually stands for diameter, so we are given the diameter of 10 millimeters, and we are given a force of 5,000 newtons, So we have to find the stress, the actual so the actual problem, what we have to find here actually is the stress. But before we can find stress, we have to find the area, because we are not given the area, but we are given the diameter and the force. So we have to find the area first. What are we going to do? We're going to use the formula of area, which is pi multiplied by diameter squared all divided by 4. It is equal to pi multiplied by, we are given the diameter, it is 10 all over 4, which is equal to, what is pi multiplied by pi multiplied by 10 squared all over 4. It's equal to 78,539, but we'll round it off to 78,54. Millimeters squared. Since we've now gotten the area, we can now do our calculation. Now we can now calculate our stress. We can now calculate stress. So stress will be equal to what is the formula? F divided by A, which is equal to the force that we are given is 5,000 Newton. 5,000 Newton divided by 78, 54, giving us 63.66. 63.66 MPa, megapascals. Don't forget, we are using what? Megapascal. So yes, that's it. In conclusion, all I can say is, let me summarize. If you are given the bar type, okay, let's say you are given a square bar. For a square bar, the formula for your area you have to use, for a square bar, the formula for area, you have to use A is equal to A squared. This is 2, not Z. This is 2. Okay. Is okay. It's A is equal to A squared. For a square bar, the formula for area is A is equals to what? A squared. So, but for a round bar, area is equal to pi diameter divided by 4. Yes, so that's it. Hope you learned something new. Yeah, thank you.